Welcome to this video. I'm going to be doing the next few problems in section 7.5 of the James Stewart Calculus Early Transcendental textbook, the 7th edition. So it's a mouthful to say that. Okay, this has been part of a series where I've been solving the problems in section 7.5. I'm just practicing a lot of integration problems. Okay, so we have number 31, integral of this square root of 1 plus x over 1 minus x dx. So how do we approach this? It's not something squared minus something squared, not a trig sub. Maybe we can force it to 1 though, actually, so maybe we can try that. It's not a simple rational function because of the square root, so we can't do like partial fraction decomposition, at least very easily. You might be able to, I don't know how when there's square roots. Not a trigonal for sure. By parts, I kind of don't want to work with the square root, so let's try to avoid that. Can we make a substitution? Let's try. I'm not sure. Actually, I do know, but let's just try. So maybe let's let u be 1 minus x. du would be minus dx. Okay, that's fine. That's dx, I could write it as minus du. That's totally fine. How can we get the top in terms of u? We can write it as x is 1 minus u. Or we just add 1 on both sides. That'll be 1 plus x is 2 minus u. So when we do a substitution, we would get square root of 2 minus u over u du with a negative sign. So now the problem is you have to have fundamentals of algebra here. You can't just break up the square root into like square root of 2 over u minus square root of u over u. You can't do that. That's not valid. Okay, we can do this though. We'll break up like this because it's a quotient. Okay, so once again, you cannot say that it's square root of 2 over u minus square root of u over u. That's not valid, okay? So if I break it up like this though, because this is valid, does it help me though? How do I evaluate this angle? Even I'm not quite sure. So maybe this is not the right method or not the best method. It might be you might be able to evaluate this, but it might be very tedious and even I don't see right off the bat how to evaluate it. Okay, so let's maybe abandon this method, at least this substitution. If we substitute u as 1 plus x, it won't really help us out that much either. Okay, so are we out of ideas? So earlier I said maybe we can force it to be a something squared minus something squared to make it a trig sub. So let's do something like that maybe. So 1 plus x over 1 minus x, that's the original guy. What if I multiply it by 1 plus x over 1 plus x dx? Okay, so why would I want to do that? Well, let's just simplify first. On the top, we would get 1 plus x quantity squared. Okay, on the bottom, we get 1 minus x squared. All right, and now, dx, let's do the same property. Since it's a quotient, we can break up the radical into square root of 1 plus x quantity squared, that quantity, not the whole radical, over square root of 1 minus x squared. Okay, now it's something squared minus something squared. We can probably do a trig sub. And actually, in fact, the top we can simplify a little further because 1 plus x squared under the square root would just give us 1 plus x. Technically, remember when you're square rooting, you have to worry about plus and minus. Well, because it's squared, the inside is always positive, so we can just leave it as 1 plus x. We don't have to worry about the negative. Okay, so it simply becomes like this. This is much easier to solve. We can do trig sub, as I was saying. So let's do it. Let's set up a triangle. Okay, So we have something squared minus something squared, so we know that 1 is here, x is here, square root of 1 minus x squared is here. Okay, I believe I did this substitution, exact substitution, a triangle in a different video, like 2 times even. Okay, so we're back to here. So we want to sub everything here in terms of theta. How do we do that? Sine theta is x. Okay, so cosine theta, d theta would be dx. And we need to get a square root term. That is just cosine. Okay, I'm getting it all from the triangle. All right, so let's substitute. I'll be 1 plus was x, that is sine theta. dx is cosine theta. d theta. Over the bottom is just cosine theta. Oh, this is much easier now. 1 plus sine theta, d theta, because the cosines would cancel. This is very easy to integrate. This is just theta minus cosine theta plus c. Okay, now we need to back substitute. What is theta? You can use any of the arc trig functions, but since we already have sine theta is x, so theta is arc sine of x. Minus what's cosine? We said here it's square root of 1 minus x squared, okay, plus c. That's our answer. It's actually not pretty simple. The trick here was we had to make this something squared minus something squared and we had to use trig sub. Okay. All right, this might require the whole page, the next problem also. So, number 32, integral square roots of 2x minus 1 over 2x plus 3 by dx. How can we solve this? Maybe let's again go down the list. By parts, it is a product of two things, but when we differentiate the square root, it'll be 1 over 2 square roots of 2x minus 1 times 2. That would be at the bottom. And then when we integrate, if dv is 1 over 2x plus 3, v would be log. And then we have a product of log and a square root on the bottom. That's even more complicated. So maybe not by parts. Not trig integral. Trig sub, I don't see as something squared minus something squared, or plus or minus something squared. So I don't see that right away. It's not a rational function. Not like, or it kind of is, but it's not a typical one that we learned in partial fraction decomposition. So how not that? So can we substitute something? Let's maybe try u is square root of 2x minus 1, because maybe I want to get rid of the square roots. I'm not sure. Okay, so let's do our usual technique. Maybe let's find u squared first. U squared is 2x minus 1. Now we differentiate. 2u du is 2 dx, or u du is dx, as simple as that. Okay, so we have this term, we have dx. How about this term? Well, we can get it from this definition. So let's take the u squared definition, actually. So u squared, if we add 4 on both sides, okay, what's minus 1 plus 4? That's just plus 3, so 2x plus 3. So we can rewrite our integral as u, what's dx? Another u du over the bottom would be, what do we say? U squared plus 4. Okay, so we can simplify u squared over u squared plus 4 du. Okay? So remember in the previous video, I did a little trick. So you can do long division here to solve it. That's totally fine. Or you can do a little trick. U squared plus 4 minus 4. U squared plus 4 du. We can do this little trick because, let me even do it slowly one more time. It'll be u squared plus 4 over u squared plus 4 minus 4 over u squared plus 4 du. I broke up this fraction like this. This is a simple 1. So, and this is arctan, so we can integrate. It'll be u minus 4 times 1 over 2 arc tangent of u over 2 plus c. And then we have to back substitute. This can simplify to 2 for sure. So u is what? Square root of 2x minus 1. So square root of 2x minus 1 minus 2 arc tangent square root of 2x minus 1 over 2 plus c. This should be the answer. You can double check my work. I did not check my answers. Okay. Oh, we have time for another one. 33. Integral square root of 3 minus 2x minus x squared dx. How do we approach this one? Maybe we can do the technique of completing the square. But before that, let's go down the list once more. Do I see an easy substitution to make? I don't, because if we let u be the inside, du would be negative 2 minus 2x, which dx, which I don't really see outside. And it would be hard to write in terms of everything in terms of u. Trig integral, no. Trig sub, we can maybe make it into trig sub by completing the square. So we'll see that in a bit. Partial fraction decomposition, it's not a rational function, so no. So let's try completing the square. But before that, remember, there's a requirement for completing the square. The term in front of the square term has to be plus 1. Has to be a 1. So let's factor a negative 1 from the inside. Negative x squared plus 2x minus 3. It'll be like this. Okay, now let's complete the square. So it'll be 2 over 2 squared, which is 1. Okay, so we want to rewrite this as square root of negative x squared plus 2x plus 1. That's from here. But originally it was minus 3. So to get back the original, it'll be plus 1 minus 4. Okay, now we can rewrite this as negative integral of, the whole point was to write, oops, the negative should be on the inside. The whole point of completing a square was to get a perfect square. So it'll be x plus 1 squared plus 4 dx. That's a negative sign. Sorry for the little mess there. Okay, so we can actually do a trig sub now. We can even do a substitution, let u be x plus 1 first to clean it up a little bit. But actually, yeah, let's do that. U is x plus 1. Du would be dx. This should be a minus, sorry, because there was a minus there. U squared minus 4 du. And let's make it a little nicer. Let's distribute back this negative sign. So it'll be 4 minus u squared du. Now we can do trig sub. Okay, so we have something squared minus something squared. So the first term has to be the hypotenuse. U has to be one of the sides. Square root of 4 minus u squared is the last side. So we want everything here in terms of theta. To get du, we need u first. Sine of theta is u over 2. So 2 sine theta is u. Let's differentiate. 2 cosine, theta, d theta would be du. Now we need a square root term. Square root of 4 minus u squared. How can we get that? Cosine theta is square root term over 2. So 2 cosine theta is square root term. So our integral becomes 2 cosine theta. That's from this term. We got that, 2 cosine theta, right? Du is another 2 cosine theta. So it'll be, we write it as 4 cosine squared theta, d theta. We know how to solve this. This is a half angle formula. So it'd be 4 times half, which is 2, integral 1 plus cosine 2 theta d theta. So we get 2 times theta plus half sine of 2 theta plus c. Here's where we still have quite a lot of work. We had to back substitute twice actually, but before that, sine 2 theta, we have to use the identity. Sine 2 theta is 2 sine theta cosine theta. So we would get plus sine theta cosine theta plus c. Okay, so 2 times, what is theta? We can say theta is arc sine of u over 2. All right, sine theta is u over 2. Cosine theta is square root over 4. Square over 2. Okay, we're not done yet. Hopefully my writing didn't get cut off on camera. This is back substituting theta. And then we had to back substitute u. So 2 times arc sine of x plus 1 over 2 plus x plus 1 over 2 times square root of 4 minus x plus 1 squared over 2 plus c. And this should be your final answer. Again, double check my work. Okay, and this is a good stopping point after a few kind of difficult problems. More intermediate for sure. I wouldn't say that any of these were quite advanced yet, but for sure more difficult than usual. Okay, hopefully this was helpful. If you got stuck anywhere, hopefully just me explaining my thought process out helped you to see how I approach these types of problems when I get, not per se stuck, but if I don't know what to do right off the bat, I just try one method. And if it doesn't work, I try a different method. Okay, so you cannot give up when you're solving integrals. Especially if you're given an integral that you for sure know is integrable. Because remember, not all integrals you can solve like a closed form solution like this. Not the nicest closed form solution, but it is a closed form solution. Not all integrals have a nice solution like this. Okay, so when you're given one that on the test or exam or whatever, that's for sure integrable, then you just got to keep trying until you get somewhere that is close. That leads you in the right direction, at least. Like here, I thought maybe let's complete the square, and then eventually I said, oh, we can do a trig sub here, and this was much nicer over here. Okay, to do the trig sub. Okay, so sometimes you just got to keep trying and persevere in order to see the light, per se. Okay, please like this video if you found it helpful. I'm not sure if I said that earlier. And also please subscribe also if you have not already, and look out for the next video where I'll solve a few more problems. So hope to see you there. Bye.